This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. Welcome to section 5.51, solving exponential and logarithmic equations. So here's what we're going to do today. We've learned about exponents and logs, and now we're just going to put them in equations and solve them. There's going to be lots of u substitutions. There's going to be quadratic formulas to solve, and there's going to be, you can take the log of both sides. Like here, you can check this out. Example 1, we've got two sides of the equation where the base is 2 and base is 2. If the bases are the same, then the exponents have got to be the same in order for this equation to work. So that's kind of one idea that you can use. The bases are the same, therefore the exponents have to be the same. You can put the exponents equal to each other and solve. You get x equals 4. So it says solve algebraically and graphically. What you could do is you can graph each half separately and find the intersection. So here's the left half, 2 to the 3x minus 7. I'm going to graph that. And then the right half is going to be 2 to the 5th. I'm going to graph that. There's actually no x here. It's just going to be a straight horizontal line at 32. But you notice what happens when you graph these two together, the answer is going to be at the intersection. You see, we had an x value. The x value equals 4 right here. That was our solution that we solved for. And if you graph it, then that's the x value that solves as well. 4 is the number that makes both of these equations. The point 4 comma 32 is on both of these graphs, so therefore the intersection represents the solution, where they're equal to each other. They're equal to each other when the x value is 4. Let's do the same thing again here. 3 to the x equals 20. Well, here we don't have bases equal to each other. So what you can do is you can just take the log of both sides. I mean, you can divide both sides by 3. You can multiply both sides by 2. You can add 4 to both sides. Well, you can take the log of both sides. You could even raise both sides to the same exponent if you wanted to. Take the log of both sides, and all of a sudden you get log of this left side is equal to log of the right side. Now, the powerful thing about that is that we remember the properties of logs tell us that the exponent on the inside becomes multiplication on the outside. This becomes x times log of 3 equals log 20. And if you want to solve for x, all you got to do is just divide both sides by log of 3, and then you get your answer. X is going to equal log of 20 divided by log of 3. That's something a calculator can handle, and you can type that in and get 2.727. Now, if you wanted to, you could. So that's basically how you solve it. You could also solve it graphically by finding the intersection of the left-hand side and the right-hand side. Left-hand side is 3 to the x, and right-hand side is 20. And so therefore you get something like this. You can graph the 3 to the x, you can graph the y equals 20, and where they intersect is the solution. The x value of the intersection is 2.727, and there it is. You can see it on Desmos. Here, we've got an exponential equation. This is 100 times e to the 0.08t is equal to 2500. Well, what you can do is you can divide both sides by 100 first to get rid of this term, and you're just left with e to the 0.08t is equal to 25. You could rewrite this as a logarithmic, or you could take the log of both sides. Taking the log of both sides turns this exponent into 0.08t times the log of e is equal to log of 25. Now, log of e is just going to be the natural log of, the natural log of e is going to equal to 1, so it kind of disappears. This times 1 is just going to be this. You notice this is going to be actually the equation you could have gotten had you rewritten this as a natural log. This, rewritten as a natural log, is this. The exponent is 0.08t, the base is e, and the power is 25, just like you see here. However you get to this equation, the next step is definitely to divide both sides by 0.08, and you get this, and you can type all that into a calculator and get 40.23, and that's the answer for t. If you wanted to, you could also determine this graphically, graph the left-hand side, graph the right-hand side, and see where they intersect. And this is where they intersect, right here. you can see this is the left-hand side with a variable. This is the right-hand side. It's just a horizontal line because there's no x here. It's just y equals 2500. And this is it. The answer is 40.236. That's the x value. When you take 40.26 and you put it into each of these equations, you put it in here, you get 2500. You put it in here. You can't really put it in here, but you still get 2500. And that's why that's how you find it graphically. Just want to pause for a moment and tell you how awesome zirconium is as an element. It's number 40 on the periodic table. Zirconium. Example 4 is 4 to the x plus 3 equals 3 to the negative x. The thing you need to notice here is that the bases would be the same. You might want to say that x plus 3 is equal to negative 6, but you can't because this is the base 4 and this is base 3. Best just to take the log of both sides, and this is what you get. The log of the log of the left-hand side is equal to the log of the right-hand side. When you bring down the exponents, it looks like this. X plus 3 times log of 4 is equal to negative x times log of 3. So here, and then let's distribute. So we get log of 4 times x and log of 4 times 3, and this is how you write it. So now we have 3 giant terms, term 1, term 2, and then over here on the other side, term 3. 2 of them have x's and 1 of them doesn't. So I'm going to gather the terms that do have x's on this left-hand side and gather the terms that don't have it on the right-hand side. Well, there should be a minus right here. Let's see. We'll just write it in. Subtract, subtract, subtract. Once you gather the terms that have x's on the left-hand side, you can factor out an x. It's the greatest common factor. You put it here, and the results are inside. Log of 4 here, log of 3 here, equals the same thing. We just recopied it. Then divide both sides by log of 4 plus log of 3, and you get that. And that's something you can type into a calculator and get your answer. You could also just graph both sides of the equation. The left-hand side could be y1, the right-hand side would be y2, and see where they intersect. They'll both have the same x and y values. It's like solving a system of equations. They have the same x values and the same y value right here. So my question to you is, do you want to calculate this using a calculator or using the graph? Your choice. You got to find out what it is. Here's another equation. E to the x plus e to the negative x minus 6 equals 0. I find that I think the easiest thing to do as a first step is to get rid of the negative exponent, because all of a sudden if we do that, we get an e to the x and an e to the x in this equation, and then we can make a u substitution. We'll let u equal e to the x. And then once you do that, it gets a little easier because you just have u plus 1 over u minus 6. Now you should take care of that fraction. It'd probably be easiest to multiply all the terms on both sides by u. So then this u becomes u squared. The u's here cancel, and this negative minus 6 becomes a minus 6u. Rearranging the terms a little bit, it looks like a quadratic formula. U squared minus 6u plus 1 equals 0. That's not something you can factor, so you can let the a value be 1, the b value be negative 6, and the c value be 1. If you plug all of that into the quadratic formula, the answers you get are u is equal to 3 plus or minus 2 root 2. Yay! Now, back substituting, we get no longer u, we get e to the x. So how do we solve e to the x is equal to 3 plus or minus 2 root 2? Well, you can take a log of both sides, the natural log of both sides, and that'll get rid of this natural log of e, and x will go out in front, and x is equal to the natural log of 3 plus or minus 2 root 2. You can take the positive version and get this, and the negative version and get this. The way to do it graphically would be to graph it. Big surprise there. Let's just graph it and see what happens. Since it's all equal to 0, we look for the x-intercepts, and there they are. Negative 1.763. That would correspond to this answer, and then this would correspond to this answer. It intersects the x-axis twice. I'd like you to begin assignment 5E1, copy the problem list, do the first problem, and I will see you in class.